Welcome viewers, this is Mr. Dingo, and I want us to move on with the previous lesson that we were taking, that is relative speed. And today I want to talk about bodies that move towards the same direction. The way we look at these cases will almost be the same, but there's some slight differences. The bodies that move the same direction, we know that the one ahead should always move at a lower speed, and the one behind will move at a higher speed. That is only the case where we can have the one behind overtaking the one in front. But if they are moving at the same speed, then we don't expect one to overtake the other one. If the one ahead is moving at a faster speed, the distance between them will keep on widening. So viewers, there's only a slight difference when we are talking about bodies that move towards the same direction. For those ones that move towards opposite directions, we were adding their speeds to obtain what we call relative speed. But the ones that move towards the same direction, we are going to subtract their speeds so that we get the relative speed. So I want us to look at an example here. Initially, we looked at bodies moving from town A to town B. In this case, I want to talk about bodies that move from town P to town Q. And I want to assume the distance from town P to Q is 540 kilometers. That's the distance between town P to Q. From town P, we have a car. A car is moving from town P to Q, and this car is moving at 110 kilometers per hour. That is the average speed. Then from town P, there's a matatu. Matatu also leaves town P to town Q, and the matatu is traveling at a speed of 90 kilometers per hour. So we have these two objects, the matatu and the car. The matatu leaves early, and the matatu leaves at 10:30 a.m. Matatu leaves at 10:30 a.m. and then 20 minutes later, that is 10:50 a.m., the car leaves town P for town Q. So viewer, we want to be able to understand. Again, what we realize in this particular case is that the matatu leaves early, and then the car leaves around 20 minutes after. So we want to still look for the time traveled, time taken by matatu before the car departs. This time taken before the matatu departs from town P will be 10:50 when the car is departing minus 10:30. This will give us 20 minutes. As I told you earlier, we need to be able to convert these 20 minutes into hours, and that will be 20 over 60 hours, which I can say is around a third hours, 1 over 3 hours. What about the distance traveled? Distance in third hours or in 20 minutes. How much distance is covered by the matatu? At this particular time, we know distance equals to speed times time. And the distance here will therefore be speed of the matatu is 90 kilometers times a third hours. That will give us 30 kilometers. So before the car leaves town P, the matatu has covered 30 kilometers away, assuming it's up to here, 30 kilometers. It means that, viewer, if we subtract 540 minus 30, we have 510. This 510 is the distance remaining for the matatu to cover. But now, because these objects are moving towards the same direction, the distance between them by the time the car begins the journey at 10:50 is actually 30, because that time matatu is here. The car is starting here, but the matatu already is at that particular point. So the relative distance, I said, is the distance between two moving objects, and therefore the distance between these two moving objects there is 30 kilometers, and this is what is very, very important in this particular question. So 30 kilometers is now the distance between matatu and the car. So we have our relative distance. Relative distance is 30 kilometers. Relative speed, I said, for more objects moving towards the same direction, we subtract. So relative speed will be 110 minus 90. That will give us 20 kilometers per hour. So the relative distance is 20 kilometers per hour. The relative speed is, the relative distance is 30 kilometers per hour. The relative speed is 20 kilometers per hour. The relative time therefore is relative distance over relative speed. And that will be, relative distance is 30 kilometers per hour. And the relative speed is 20, relative distance 20 kilometers, this is 20 kilometers per hour, sorry. So if you divide this one, we'll get 1.5 hours. So 1.5 hours, viewer, is the same as 1 hour, 30 minutes. That's the time taken for the car to overtake or to catch up with the matatu. So if you are asked the time of the day when the car caught up with the matatu, we are going to say the time of the day, the time taken for it to catch up is 1:30 minutes, and the car leaves at 10:50. So we are going to say the time of the day is 10:50 plus 1 hour 30 minutes. This one will be 0. We know 80 minutes, 30, 50 plus 30 is 80. So we carry 60, which is 1 hour. We write there 20, and then we bring that 1 hour here. That is 11 plus 1 is 12. So we are going to have this particular matatu and the car meeting at 12:20 p.m. That is the time when the car will catch up with the matatu. If you are asked to find again the distance from town P where they met up, the particular specific point from town P where they meet, when the car caught up with the matatu, we are going to take the time taken for these bodies to move. And I'll quickly just use the car, because the car is traveling for 1 hour 30 minutes, that's 1.5 hours, and the car's speed is 110 kilometers. So distance from town P where they caught up will be speed times time. And in this case, I want to use the car speed. The car speed is 110 kilometers per hour times time. The time, which is the relative time in this case, the time taken for the car is 1 hour 30 minutes, which is 1.5 hours. If I do that, viewers, I'll have 1.5 hours times 110, and that is 165 kilometers. So viewers, we can now say that the car, or the distance from town P where the matatu and the car met is 165 kilometers. Viewer, that is very important that you learn this particular case. And there are many other examples that could be having a little complications. If you have any questions, don't hesitate to contact us with those questions. We'll be able to answer for you those questions in real time. Another issue that after this lesson, please take a few questions that appear on your screen so that you can answer them. And next time we'll give you their answers. Thank you. You are most welcome.